Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the Optical Flow Node. So we're going to jump into Fusion and we're going to hit Shift Space and bring in a Optical Flow. Now, what the Optical Flow Node does is, in a nutshell, it just adds vector data to your footage. So if we look at our footage right now and we right click on our display and we hover over channels, we can see we have our color channel, our red, green, blue, and alpha. Those are the only channels that we have on our footage. So we covered the other day talking about the time speed and the time stretcher and how it skips frames and adds additional frames or drops frames. What the Optical Flow Node does is it calculates in between those frames and it will give vector data so we can make up pixels or create pixels. And it calculates on a pixel level. And additionally, it calculates both forward and backwards because some nodes need forward and backward data. Some nodes need only forward data. So let's go ahead and input this in. And now if I look at this node, I right click and go to channels, we now have vector channels. We have our X and a Y, and then we have back vectors, X and Y. So what this node is doing is it's calculating per pixel, per frame, what's going on in between. So if I find, so this frame right here, so we've got her hand up here, and if I go to the next frame, well, that's not a good example. Let me find a better example. Right there. So her hand is up here, and if I go to the next frame, her hand is all the way down here. So if we do slow motion, it has to figure out those in between frames, and that's what the Optical Flow Node is going to assist you with. So it's gathering that vector data of all these pixels on the speed and the location. And if I actually view our vectors, you can see what it's doing to our image. It's adding that speed and location information for all our vectors. And I'm going to leave it on this right now as we go over some info. So the Optical Flow Node itself, other than calculating pixel and vector data, it does nothing else. It needs other nodes to actually work with. And up top, we have two modes. The advanced mode is going to use your GPU, while the classic mode is going to use your CPU. So we'll cover the advanced mode first. Now, what this warp count does is it's calculating pixels in between and kind of warping from one frame to another. And this warp count allows you to increase or decrease the warp count to give you more or less detail. If your computer is having issues calculating all this, you can lower your values to speed it up a little bit. But this will dictate how that warping looks. Your iteration count is actually how many iterations there are between those frames. So we can lower it or we can raise it. And again, with this iteration count, it's going to increase or decrease your processing speed. So we will go ahead and leave that at the default. And your smoothness is just going to smooth out that flow data. So higher smoothness values are going to kind of help with noise, and lower values are going to bring out a little more detail in that. And your half resolution is exactly that. It's going to half your resolution of your image while we play back. And speaking of resolution, let's go back to our color channel. Our media here is 4K footage coming in. So it's going to be pretty intensive on our computer here. You can see we're playing back at 5.2, 5.3 frames per second. It's pretty slow, and this is a beefy computer. Now, if your computer does have problems processing this optical flow data, there are workarounds, because the main thing we're doing is we're just trying to pull that vector data, and there's other ways to get vector data. So if you're having issues with this optical flow, you can go to your Optical Flow Node and get your settings, how you want your settings. And we can add a saver node. And input that to our saver. And if we go to folders here, we can create a new folder. Let's say OptFlow. And we can save that information or select it. And then once you have that information saved, you can go up to your Fusion and hit render all savers to render everything. So we'll go ahead and render this out. And once your render is complete, we can actually disconnect this. And if we add a loader node, we can find our info, bring it in. And now we have our footage as an EXR. And if we go to our channels, you can see we have that vector data on our info. So this may help you play it back faster, and it may not. So I'm going to go ahead and get rid of these. And we'll plug this back in. Now, under your classic mode, like I said, this mode uses your CPU, and it's kind of the older version, and it's mainly there for if you do have older projects that you use this on. But you can use it if you want. And right here, this is a proxy slider. And what this does is it offers sped up proxy tracking for this. And when I say tracking, I don't mean motion tracking or like a planar tracker or anything like that. That means tracking these pixels so it can add that data into it. So right now with a proxy scale of 2, it'll give you a 4 times speed up. If we move it to say 3, it'll give you a 9 times speed up. So that's what the proxy for tracking node does. It helps speed up that process. And in the advanced controls under the classic, we have smoothness, which will help smooth out that information. We have edges, which will help refine the edges within the new data that it's creating. Match weighing will help control the threshold of neighboring groups of foreground and background pixels. Your mismatch penalty will control how the penalty for mismatch regions grows as they become more dissimilar. So we can lower it to increase our threshold of where that changes. Our warp count is the same as our warp count in our advanced mode, and our iteration count is the same as it is in our advanced mode, and our filtering just gives us the ability to select bilinear or Catmull ROM, and that's just how it will filter out those pixels. So let's go back to advanced mode because this is what we're going to use and probably the fastest and best mode to use, and we're going to give it a playthrough real quick. And there we go. And I'd like to just play through my footage to make sure this optical flow node is collecting all that data correctly. Now, once you collect it, if I select our media out, right click, you can see we still have those vectors. So it's pushing that vector data all the way through. Now, mind you, some nodes are going to eat this data or destroy this data as it goes through. So if we bring in our time speed, say from yesterday or the day before, and we input it into our footage, and up here select flow, now we're using that vector data to calculate between our frames instead of the nearest or the blend. So if I reduce our speed, let's say to 0.25, and let's find an area where our hand was going up. There we go. So you can see what this is doing is it's using the optical flow data instead of having her hand here and then the next frame up here. It's giving us this information in between to help it flow better, so it's smoother. Now on our time speed node that we covered the other day, since I didn't cover this stuff, your additional settings are your dithering order or your depth order. Sorry about that. And you have two choices of fastest on top and slowest on top. Now what this means is, let's say this is a lockdown camera shot and it's getting a picture of or a shot of someone running through a park in the background. So there's a lockdown camera and you have a jogger running through the park. Now the jogger, since the jogger is moving fast, we would want our fastest on top since our background being the park and the shot and everything is not moving. So we would have our fastest on top. Now, if our camera wasn't locked down and we were following that jogger, so the jogger was pretty much still in our shot, but our background was flying by, we would want to select slowest on top since our jogger, being the subject of the footage, is moving slow and our background is moving fast. So that's what depth ordering means. So in this shot, most of our stuff, our camera is locked down and everything is moving around super fast. So I'm going to select fastest on top. Our clamp edges, what this does is, if you notice, we've got all this pixelation and all these empty pixels here on the side. If I select clamp edges, it's going to remove those. Once I select clamp edges, I have this additional edge softness. And what that is going to do is it's going to help fix some of these weird things going on the side. And there's no one setting. You just have to kind of play with it till you get it to look the way you want it to look. So what your source frame and warp direction are doing is it's selecting what vector to use and what direction to use, whether we're using our forward vector or our backward vector. So right now we have our forward vector being selected, and with the previous frame selected, that means we're taking the previous frame and using the forward vector to interpolate our new frame. And with our next selected, we're taking the next frame in the sequence and using the forward vector to interpolate the new frame. So this will change your look. So if I decide to use our back vector instead, you can see how our look just changed. So this is all dependent on how you want your look to look. So I'm going to reselect previous and next on the forward. So now if we play, we're playing at 25%, and it is using the optical flow data to fill in those frames. And you can see it looks a little odd. So this is where you would go back to your optical flow and play with your warp count, your iteration, and your smoothness to fix how you want this to look. So if we increase our warp count, we're going to smooth out some of that stuff, and our iteration count and our smoothness. So you can see how all this affects the look of your footage. So now if we play it back, we've got that. Now, mind you, I mentioned some nodes destroying your data. if I now look at our media out and right click, you can see our channel no longer has vector data. That's because our time speed node destroys that vector data as it uses it. So if you need to use optical flow on other nodes down the line, you're going to have to reintroduce a new optical flow node to bring that data back. Same goes with our time stretcher. So if I bring in our time stretcher, and that's one thing I forgot to mention. Wherever you are on your timeline, when you bring this time stretcher in, that's where it's going to add that keyframe that automatically gets added. So you can see it just added a keyframe here in the middle, but I can get rid of that, go to the end and reintroduce our 0. So if I wanted to say go here, and we're going to make this frame 120, so it speeds up super fast. And then make this frame, we'll say, we'll go here and say frame 200. And then we'll go here and we'll make this actually go backwards to 0. And if we play, you can see right now we've got it on blend mode. So let me actually bring this to one of our slow ones. Now her hands, you can see we're blending using our sample spread that we used the other day. But if I bring it to use flow, now it's going to use that optical flow data to interpolate between those frames. And we have the exact same menu as we did for the time speed with our clamp edges, fastest on top, slowest on top, our edge softness, and our source frame and warp direction is all the same. So now if we play that back, you can see it's using that flow data, that optical flow data, to make our transitions a little smoother. So it's not so jittery. So that is much smoother footage than using our nearest or our blend. So we'll delete that. Now there's other nodes we'll use this for, and we will cover that later on other days. But if you remember our vector blur, our vector motion blur that we used, and instead of our vector X and our vector Y, we chose what color channels we were going to use when we brought that EXRs in. This vector motion blur lets you use the optical flow data using that X and Y channel, or that vector X and vector Y channel. And on our vector motion blur, if I go to our media out and right click, you can see it did not destroy our vector data, so it is still there. So good practice while you're using nodes like this, like the optical flow, and you're dependent on that data, just every once in a while, right click up here and see what channels you have available to make sure your vector data isn't getting destroyed and you're spending a few hours trying to figure out why you can't get something to work correctly. So on our motion blur, we can go in and we can scale up our motion blur, and it's going to use that vector data to add more motion blur to our footage. So now if we play it, we got some crazy motion blur going on based off of our vector data that we're bringing in from our optical flow. So that is the optical flow node. I will see you in the next node breakdown.